because I am joined again by a friendly neighbor to my north. Ron Lancaster is an associate professor in mathematical methods at the University of Toronto. Ron, welcome to the 24-hour Math Magic Show.
Hey, Sam, thank you very much. I'm glad I'm not doing this at 3 in the morning.
Oh, I mean, so am I. So am I. I'm
Sam,
glad.
I just caught the end of Gord's session, and I don't know why, but something was jumping out at me about nomograms. So, you may have seen these before, but this is a nomogram for solving a quadratic equation. And it's got a couple curves. You use a straight edge, you join a couple points, connected to the quadratic equation you're solving, and poof, you get your roots. But it's all arranged in a really intricate way, and it kind of reminded me of. I didn't see what Gord was doing. I didn't see his whole talk, but somehow it reminded me of that.
Oh, that is very interesting. I'd never heard of nomograms before.
Yeah, that's out of a really old book by Jerome S. Myers called More Fun with Mathematics, which is what this show is all about.
Oh, I mean, definitely. And one way that you help people have more fun with mathematics is that you create mathematical activities. So, what does that sort of mean? What goes into creating a mathematical activity?
Well, my activities are quite wide ranging, but a lot of them are connected to the world around us. So something that's a big part of my professional practice are developing math walks, where I take people out on a math walk. I started doing them when I was teaching at an all-girls school near Toronto. And then since then, I've developed these all over the world. And kind of taking, what's in our view, in our surrounding, and turning that into a really rich learning math task, for students. And it's a really nice way for students to be active, to get up, get out of the classroom and go see where math lives. So that's been a big part of my practice.
Well, that is fascinating. I mean, I personally don't live that far away from Toronto, and when Canada is once again welcoming U.S. citizens across the border, I would love to come do a math walk
And
with you.
Sam, I'd love you to come and visit me. And I'll take you on a walking tour of Toronto, but we'll do it through a mathematical lens.
Oh,
So we'll look
I'm
at the city that way.
I'm so
And,
excited.
yeah, you get to see a wonderful city, but you'll also get to experience it, through mathematics and seeing the city.
Okay, well,
Yeah.
I'm now really glad that you ended up on my block while I am the host here. I
What part of Michigan are you in?
I am in Ypsilanti near Ann Arbor.
Yeah, sure. Yeah, so my father was born in Detroit, and I had an aunt and uncle who lived in Detroit. The family had, I think, 12 kids. So I have 12 cousins. They're kind of spread around the US now, but some of them have stayed in Detroit. And I grew up in Chatham, Ontario, not too far from Detroit. So Michigan and Detroit was really big when I was young for me. Toronto was not like a big mecca city like it is now. For us, it was Detroit. I mean, that was our, big city.
Yeah, Detroit has been one of my favorite cities in the United States for a very long time.
A remarkable place. I've also got into a small town in Michigan called Colon, and it's the magic capital of the world. And they
Really?
have an annual magic festival, and it's held every year. There's literally thousands of magicians that come. There's not enough hotels in the area, so people, they stay, they camp, they stay with people, and the reason it's there is there was a company called Abbott's that manufactured a lot of magic equipment, and they were based in Cologne. And so they had this annual Magic Fest, an amazing time. You'd walk out in the streets of Cologne, a tiny town, and you just see people doing magic on the streets. Just remarkable stuff.
Wow,
Very cool.
fascinating. I had no idea. Now I have a new place in Michigan to go visit.
Absolutely.
And while we are speaking of magic, do you have a magic trick to share with us?
I do. So, Sam, I have a couple things. So, they both involve dice. One of them involves cards and dice. So, in the one of them, I'm going to go through an explanation of why it works. And in the second one, I'm going to leave it open, but I'm going to provide people with some, ideas of how they could explore it. And in both of these, I want to turn this into something that a math teacher could also do, because there may be some math teachers tuned in, probably a lot of them, and with some ideas of how they could turn this into an activity that they could do with their students, as well. And then at the end, if there's some time, I have some resources sitting beside me, some books that have been really important to me. And I wouldn't mind taking a couple of moments and just, showing the books and letting people know that if they want more information, of course, there's tons on the web that you can find, but there's also some amazing books,
I'm
that are out there.
I am a librarian. I am more than willing to give you some space to share some books with us.
That's great because there may be some new ones, Sam, that perhaps you haven't seen, and that you could add to your library. And maybe another time, Sam, you and I can talk because I have a pretty rich library here at home, rich in the sense of the kind of books that are here that are mathematical. And maybe I could share a list of some of my favorite books that you could put into your library.
I would be happy to. We can discuss that
Another time.
offline sometime soon, and
Absolutely.
I look forward to that. But yeah, if we could
So,
see
do you
one of
mind
those
if I
tricks,
share
yeah,
my screen?
please feel free.
Okay. So, I'm going to share my screen here. This may take a moment here just to set up here. So, okay. And so here we are. Okay. So Sam, if you could just check if you could tell me if you could see a mat here with some dice and a prediction here.
Yep, I see a 2 and a 3 and a blank white piece of paper.
That's beautiful. So with some pattern, with a story, this trick could be turned into something that would be really interesting and dramatic. I'm not going to get into the story here. I'll just show you the way the trick works, what happens. So the idea is that you take a pair of dice and you can have somebody roll them. So they take the dice and they roll them, and you can just tell them stop whenever you want. So how about Sam, for you, you can just tell me to stop whenever you want. And for the audience, you and I haven't prearranged this. I haven't kind of told you to stop when it's, in a certain place. You just tell me when to stop.
Stop.
Okay. So Sam has had me stop when there's a 3 and a 2 here. So the idea in this trick is that you take the top two numbers and you multiply those together. So that's 2 times 3. Then you take the bottom two numbers and you multiply those together. 4 times 5. Sam, if you don't mind just keeping track of these. So we had 2 times 3 being 6. There's 4 times 5 being 20. I'll give you a second just to jot that down.
Okay, got him.
The first product is 6. The second product is 20. Then you take the top number of the one die and you multiply it by the bottom of the other. 2 times 4, so that's 8. And then you take the bottom of this die and you multiply it by the top of this one. And so that's 15. So Sam, you have 4 products, that you have now. Those 4 products, we could do a number of things with them. We could multiply those 4 products together. And it would be interesting for teachers with their students to do that and just to see what kind of products do you get when you do that with the 4 products. So everybody would have a different roll of the dice and they would work out their 4 products, multiply the 4 products together, and then look at them. But Sam, what I'd like you to do is to add up the 4 products.
Okay.
So I have a prediction here, Sam. It's been sitting here in full view the whole time. What did you get as your sum?
Provided that I was able to do my addition correctly, I have a 49.
So 49, fantastic. So inside here, I have a prediction, as I say, that's been sitting here the whole time. And my prediction was that you would end up with 49. I knew that you would get that. So, as I say, Sam, with the right, pattern and story, this could be turned into, something that's a bit dramatic and interesting, for an audience. Because you can kind of sense that it's mathematical. I think the average audience could as well. You'd want to dress it up some way to camouflage the fact that there's some math involved. But the fundamental question here is, why does this work? Why do you always get 49? And, if a teacher's going to use this with their students, it's an opportunity for them just to turn it over to the students and say, so, go at it. Like, what do you think? Try a number of rolls, see what happens. Now, Sam, you and I know this, and, there'll be some people who know this as well. But in a pair of dice, opposite numbers always add up to 7. And that's actually what's going on here. So this 2 right here, underneath of it is a 5, because 2 plus 5 is 7. And the 3 underneath of it is a 4. 3 plus 4 is 7. So opposite numbers on any die, they always add up to 7. And so if you want to analyze this mathematically, you could call the top number of this die A. So you let A represent it. Now, I don't mean EH. In Canada, we say A a lot. So I don't mean that EH. I mean, the letter A. Sam, it's a bad joke. Sorry.
No, I like it. I really enjoy some good Canadian stereotypes.
Good. Yeah, good. Yeah. A John Candy kind of stereotype. And so we could let the top number of the other die be B. So we have an A and a B. And the first product that you did, Sam, was A times B. So you had specific numbers for it. But in this case, we have, some algebra being used. But the important thing is that if the top number is A, the bottom number is 7 minus A. If the top number is a 1, then the bottom number is 7 minus 1. So using a bit of algebra, you can actually show why this works. These are the 4 products that you had. That's the product of the 2 top numbers. That's the product of the bottom numbers, product of a top and a bottom and a bottom and a top. And so when students are in Ontario anyway, when students are in grade 9 here, they spend a lot of time working on things like this. And this is what it looks like in a math class. I know for some people this may bring up bad memories, but this really isn't that complicated. There's a thing called FOIL. You multiply the first terms, the outside terms, the inside terms, the last terms, and you multiply it all out. It's the distributive law. And the really cool thing that happens is you have an AB and an AB. There's a minus AB, a minus AB. They all cancel off. There's a 7A. I think actually one of the Monkey songs began with 7A, a Daydream Believer. So if you listen to the beginning of that song, they're tuning up their instruments. And I think Mickey Dolenz says 7A. Anyway, I digress. So there's a minus 7A and a plus 7A and a 7B and a minus 7B, and it all cancels out and you end up with 49. So, from a mathematical point of view, this is why it works. But I think what's really important in a math class, or even with parents, if they want to do this with their child, is to ask what if questions. So this is what it looks like with 2 dice. What would it look like with 3 dice? So how would you do the trick? What would the products be? And let students think through that. In the first example, there were, a set of 2 products. We were multiplying 2 numbers together. So presumably here, we would multiply together 3 numbers. Well, what are all the products? Well, I guess you multiply the tops together, multiply the bottoms together, and I don't know, I guess maybe the top of this times the bottom of these 2, and so on. So it'd be a great exercise for students to try this, and just see, does the trick work here? In the first version that I showed you with the 2 dice, it added up to 49, which is 7 times 7. I wonder with 3 dice if it's 7 times 7 times 7. We'll find out. People can do it. And Sam, this is what the algebra looks like for 3 dice. And, I'm not so sure I necessarily want students to expand all this out. I think the really important thing is just thinking through what the cases are. because you could turn to Wolfram Alpha or something like that and have Wolfram Alpha do the algebra. Or you could work it out. I mean, it's not horrendously bad overall. And it turns out the trick works. And it's 7 cubed. It's 243.
So they're I mean that's fascinating and great. I also want to point out that being who we all are, I immediately had tried to solve it in a different way. So I actually had a different set of algebra where I uh, abstracted it out a little bit more. So I just did a plus b is 7 and d plus c is 7, and then did the all of the different sums that way. And so it's really cool to think that it works in different ways. And we did have a question in the chat, because there's been a decent amount of chat going on. The question is, if there are D8 dice, would it then be 91 or 81? I'm sorry.
Oh, that's beautiful. You know, if I was a student in my class asked me that question, I could honestly say, don't know. Let's investigate. Let's find out. It's okay for a math teacher to say, I don't know. Let's find out. So I'm not sure, Sam. And by the way, particular to your solution, that's actually really wonderful, because these days all over the world, math teachers are expected to embrace other ways of doing problems. You know, there's not just one way of doing a problem, you know, my way. You know, we're trying to get students to solve things in different ways, because if you and I were in the same class solving in different ways, we could confirm each other's result, you know, which is, we'd have a James Brown moment. You know, we could feel good about our, you know, do you feel good? We could feel good about our answers. And if I had something different than you in our final result, then we could argue out as to, well, why did you get this and I didn't? So I love what you did. And I have to tell you, Sam, I never thought of doing it that way. So, like, that's really cool. It's lovely.
Yeah.
So, yeah.
And
so, Sam, I have the second one.
Oh, yes. Yeah.
Comments in the chat about that one?
About the one that we were just talking about?
Yes. Yeah.
So there were some people who were trying to work it out, and then the other things trying to expand this out even further with a just a complete proper conjecture. So for X dice within sides, should you get into the X?
Wow.
And that is, of course, any dice that has a side that is flippable, because that is an important
yeah. Wow, that's really beautiful. You know, this is interesting because in many ways, this is a low floor, high ceiling activity. So it's low floor in the sense that it's accessible. Anybody can get into this. Anybody can do some mathematical thinking, but it's high ceiling in that you can go to the moon. You know, like what we hear somebody doing here, you know, where it's just like, whoa, you know. So it's interesting that it has a lot of places you can go to with this. So even though some might feel that the magic trick is a bit lame, I still think that with the right story and the right pattern, you can make it interesting. But whether you can or not, the activity is really interesting. You know, there's so many different things you can do with it.
Yeah, and I especially like when you add those extra dice and you're even adding a little bit of a combinatorial element, because you have to figure out how many different combinations you have.
Yes. Oh, you know, I forgot to say something. I just ordered some things from Math Gears. It's out of the UK.
Yes, we have had one of the founders of Math's Gear already on today, Matt Parker, and I'm not technically supposed to measure, but maybe you might see some other ones. Also, there are some spoilers for future guests in my room, but I'm not going to tell you what they are. I just wanted to throw that out to the audience.
Yeah. Well, this is what I ordered from Math Gears. They're binary dice. So they've got zeros and ones in them. And so it's interesting to ask what would happen with that trick if you use these dice, you know, and rolled these. You know, opposite sides add up to 1. So I just throw that out there. I threw them out. So there they are.
Maybe you could even do something with the ordering so that instead of 1, if there's a 1 and a 0 left to right, that is equal to 2. Whereas if it's a 0, 1, that would be equal to 1. 0, 0 would be 0. 1, 1 would be 3.
Yes. Yeah, absolutely. Or, you could even do something with the Sickerman dice, the Citroen dice. They're like non-standard dice. Maybe I can mention more about those at the end. So this second one involves 3 dice. And I've made a prediction here. So there's a prediction of something that's going to happen. And these cards, by the way, they are really mixed up. So they're all mixed up, the cards. And so I'm going to roll the dice here, Sam. And again, you just tell me when to stop.
Okay, stop.
Okay, right there?
Yep.
Okay, so there's a 4, 6, and a 2. So that's what I have in front of me. And 4 plus 6 plus 2 is 12. So I'm going to deal 12 cards. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I had no control over the dice that you chose. Now what I'd like you to do is to take one away. So do you want to take away the 4, 6, or the 2?
Let's take away the 6.
Okay. So the 6 is gone again. That was your choice. I'm not in control of that. So I'm now going to deal 6 cards. And I'm going to do it 3 times because we had 3 dice. So 1, 2, 3, 4, 5, 6. Rest of the cards go on top. And then 1, 2, 3, 4, 5, 6. Cards on top. We're kind of randomly getting these cards mixed up. 1, 2, 3, 4, 5, 6. Cards on top. I had absolutely no control over the 3 dice you chose or the one you chose to take away. But the top card here that we're left with here, this card is an 8 of spades. And my prediction was an 8 of spades. So that's the card that I had predicted before I started. And again, with some pattern and with, a story, the trick could be turned into something that's quite beautiful. But this one is really perplexing because it was a little bit of you and a little bit of me in dealing the cards and some choices I made. And yet, my prediction always comes true. This particular trick I found in one of my all-time favorite books. It's relatively new, but it's Mathematical Card Magic by Colm McCoy. So Colm lives in Atlanta, Georgia. I had the pleasure of staying at his place a few years ago. I was creating a math walk in Atlanta, Georgia for the Gathering for Gardner conference. And I got to know Colm, and he's really into mathematical magic. And Sam, I don't know if you've seen this book or not, but it's just unbelievable. It is just so well written. It has got lots of diagrams in it, explanations, and this particular trick comes from here. And it's just fabulous. So if you're interested in mathematical magic, this would be a terrific book to get, Mathematical Card Magic. It's interesting too that one of the things Colm does, and this is really typical of magicians, he goes through a history of this trick. So there's components of it that are original to him, but he does a deep dive into where all of this comes from. Magicians do this a lot. They're really careful about, talking about where things come from. I wish there was a bit more of that within the math community, because I'm pretty well versed in recreational mathematics and the works of Gardner, but I oftentimes see people doing things and there's no conversation of where this come from. It's not as if they're passing it off as their own, but there isn't just any kind of effort to say that, this was developed by so-and-so and, just to honor people who have come before and the work they've done.
Of course, I as a librarian, citing your work is very important to me.
Absolutely, yeah. So for people who want to figure this trick out, what I'd suggest that you do is take some index cards and number them. I have a commercial product I bought here, but just take some cards and number them 1, 2, 3, 4, 5, 6. Just number them out and go all the way up to 18. Because 18 is the highest number you can get with a roll of 3 dice. So, and then take your cards Have somebody roll the dice. You roll the dice and roll them. Count off that many cards. Do it face up. So do it face up. If somebody rolls like 10, count 10 cards, put the rest on top. You have to take one away, right? So first of all, if the total is 15, deal 15 cards, like what I did. Take one away. If the total's 8, deal 8 cards 3 times. You keep putting the rest on top. And then just look at the cards. Look at how they're arranged. Because see, now you know what the starting was, and you can see what they look like at the end. And, you'll be able to come to some conclusions about how the trick works. Again, I'd rather kind of not divulge this one because I want to give everybody a chance to kind of play with this, and just see if they can come up with something.
Oh, of course, of course.
Yeah.
We have a couple more minutes here, and so if you wanted to share a couple of those books that you were looking to share, it'd be great.
Absolutely. So Sam, for me, it all began with Martin Gardner. Any book by Martin Gardner is worth its weight in gold. So this is Mathematics, Magic, and Mystery. This is where I started learning about some mathematical magic. So a fabulous book. So anybody interested in mathematical magic should, really think about having that book in their library. Also for me, there's another magician who was also quite huge for me, and that was Paul Curry. So Paul Curry was an amateur magician. I think he worked for an insurance company, and he has a trick called Out of This World and other tricks that are very mathematical. So you'd have to probably go to a magic shop to order these. But Paul Curry, contemporary books, Brent Morris, PhD in shuffling playing cards, the Pharaoh Shuffle, incredible. So, and he has a commercial book that you can buy. This is actually part of his PhD thesis that I have in my hands here. So, but a remarkable guy. So Brent Morris, and it's the perfect shuffle. So, and he also relates it to computers and computer dynamic memory. So it's not just playing with cards, but that's contemporary. Another book I have that is amazing. The jackets come off of this, but this is by one of my favorite mathematicians who recently passed away, Ronald Graham. Incredible. And Percy Diaconus. Oh my goodness. I mean, these two giants are unbelievable. But this is Magical Mathematics by Ron Graham, Percy Diaconus, and wow, this book is just filled. I mean, I know that there's not a lot of diagrams in here, but it's filled with a lot of mathematical magic tricks.
Yeah, I am also a happy owner of that book, and I was lucky enough to meet Ron a couple of times. And
oh, you're lucky. I never did.
Yeah, just a wonderful person and a wonderful mathematician.
Yeah. Have you come across Juan Tamaris?
I have not.
Wow. So this is called Verbal Magic. And you're in for a treat with this book because this has got all kinds of, kind of self-working mathematical magic in it. And this thing is unbelievable. So Verbal Magic, Juan Tamaris. And there's also another contemporary, Jim Steinmeier. So you probably have to order these through a magic shop. I don't know whether you can get these online. I'm not sure. I have quite a few books that you can't even buy in a magic shop. Some of them were privately published. I happened to be at somebody's lecture, and they were selling private notes. But these are available maybe only through magic stores. But Jim Steinmeier has a series of about 8 books, I think. And they're all kind of self-working mathematical tricks. And they're really cool, these books. So I love his material.
That is absolutely wonderful. And Ron, thank you so much for sharing these tricks and this wonderful collection of books with us today.
Fantastic, Sam. Very nice to meet you. I hope we meet sometime in Toronto.
I do as well. And thank you again for being a part of the 24-hour Math Magic Show.
Fantastic. Good night.
Good night.